Alright, so this is my intro video to correlation and regression. Again, this is for undergrads who are in a non-stats heavy course. You should look at my t-test video, and that'll give you some background on who this is for and some of the key things that you're going to need to know before this video. And I'm going to put the link to that in the description of the video. Alright, so let's take a look, and what we're going to be talking about is correlation and regression. All right, these are tests to see if two variables are related. So let's imagine we have a population of lizards, and we go out there and we sample a bunch of female lizards. We record their mass at maturity, the number of eggs they lay in their first clutch, and their longevity. All right, so we have these three variables. Now here I have some of them plotted. I have the number of eggs. This is not a great looking figure, but it's good enough to take a look at it. This is the number of eggs correlated with the mass of the mother, and this is the longevity correlated, or at least shown in its relationship with the mass of the mother. So what can we do? We can say, all right, are these variables correlated with each other? So I'm going to go here to data. If you don't know how to do this, see my t-test video, and data analysis and correlation. The input range, I'm going to select these three. They're grouped by columns. Labels are in the first row. And let's put the output right here. Boom. Alright, so what do we have? This is a matrix that shows the correlation coefficient of these three variables, and we symbolize correlation coefficient as R. Okay, so this right here is the R for mother mass and maturity and the number of eggs. This is the R here for number of eggs with mother longevity. So this R is 0.437. This R over here is negative 0.257 with rounding. Alright, so what does this tell us? R ranges from -1 through 0 to +1. Okay? 0 means there's no correlation. Okay? 1 would be a perfect positive correlation, meaning that all of the points line up exactly on a straight line. So if we were to plot it, right, so these points move all over the place, all the points would be exactly on a straight line. In this case, this is what a positive correlation, not with a R of 1, but a positive correlation looks like, because as one variable increases, so does the other variable. They both tend to increase at the same time. A -1 would be a perfect negative correlation. Right? This is a negative correlation, not a perfect one, but it's negative because as one variable increases, like mass, the other one decreases, like longevity. Alright, and so here if we look at that one, mass and longevity, we see that it's negative 0.605. So there is, you see that the dots are not exactly along a straight line. It's almost never going to happen in biology that you find that. But as mass tends to increase, longevity tends to decrease. And it's a pretty good correlation. So it's negative 0.605, right? So it's approaching -1. If you notice, this one is 0.437, which would imply it's not as strong a correlation. And here you see that the points are a bit more spread out, but it still looks like it might be a good correlation. Okay, so these are the correlation coefficients, and the closer the number is to 1 or -1, the stronger the correlation, and the sign of it will tell you the direction. Is it negative or is it positive? Okay, but we gotta remember, these are samples from a population, so we can't say just by looking at this number if this is a statistically significant relationship, right? So let's look at this one, which is longevity and mass, right? So it appears that as mass increases, longevity decreases. But again, it's a sample from a population. We need to do a statistical test if we are going to determine that it is significant, that it really matters. So what are we going to do? There are ways to do this with correlation, but in Excel, the best way to do it is to do what's called a regression. And I'll talk about regression a little more specifically shortly, but here's regression and how we do it. So data analysis, regression, okay. The Y range, so the Y range in this one is going to be mother longevity. That's the Y value. So let's select these numbers here. The X range is going to be selecting these here. This is very much like what we did with the t-test. We have labels. We're going to have an output range. Let's put it right here. All right. Oh, dang it. You got to be careful. I was not careful and I screwed that up. I was not in the right box. Now I have to come back here and reselect the Y range. Okay. Everything looks good. If you don't know what you're doing, don't mess with the rest of these options. Okay? Hit OK. Boom. Here is our output. All right. So what does this tell us? If we're just looking at the correlation, right? So all we're interested in is, are they correlated? Is there a relationship between the two? Then all we need to look at is this value here. The significance F. That here, right there, is our p-value. Look at the t-test video if you're unsure what that means. But that is the p-value of this particular correlation that we just did. All right, so what could we say? We could say longevity and mass are negatively correlated, but now we know that they're significant, so let's put our significantly negatively correlated. How do we know? We can put R equals negative 0.605. That's what we got from here. And we should put our sample size. What's our sample size? 23 is equal to 23. And then we have to report our P. Our P is equal to 0.002. Okay? So that's what we could write in our lab report. Longevity and mass are significantly negatively correlated, and we give the information for that there. Okay? That's a correlation. That's all you have to do. All right? Very simple. You're just saying if there's a relationship. Now, if you want to get a little more complicated, then you can go into regression for real. Okay, what we did was we just used regression now to calculate the significance of the correlation. But let's say we think that one variable directly influences another variable. Okay? So think of it this way. Correlation just says two things are related. Let's say you are in a neighborhood and you look across neighborhoods and you see how many houses have pools and how many cars there are in that neighborhood. And you would probably find that in neighborhoods with more pools, there are more cars. But you don't think pools are causing there to be more cars, or cars are causing there to be more pools. You just think that they're correlated. Right? They're both probably caused by income. So if you measured income, you might say I think income is predicting the number of cars in the neighborhood or predicting the number of pools in the neighborhood. That's where you want to have regression. So with regression, you have, I'm going to, I'll leave this stuff here, but with regression, you have an independent variable. Oops, I was typing and it didn't show up. An independent variable, which is what we would call x. This is the one that causes or influences the dependent variable, which is our y. Okay, so let's say, and it makes sense, we'll say the mass of a mother at maturity affects the number of eggs that she has in her first clutch. You wouldn't expect the number of eggs to affect her mass, right? You would expect a bigger lizard is able to produce more eggs, and she'll have more eggs in her clutch. You don't think for some reason that she has a big clutch that's giving her more mass. Okay, so you would think that this one, mass and maturity, is going to be our x, our independent variable, and number of eggs is going to be our y, our dependent variable. Okay, so it looks like they might be correlated, but we are going beyond that. We're saying that one is affecting the other, so let's do a regression. All right, so to do a regression, we go data analysis, regression. All right, our y range is going to be the number of eggs. Our x range is mass. We already have that in there. And output range, just what the heck, let's just stick it in the same spot. It's going to give us an error message. We want to go ahead and overwrite the other data. Boom. All right, so now what we've done is the regression for mother mass at maturity. That's our x or independent variable. Okay, and number of eggs is our dependent variable. So what do we see here? If you look here, this is our multiple r, 0.437. That is the same thing as our r up here. Okay, gotta be careful. Excel will always give you a positive multiple r. Okay, it's always gonna be positive, even if it's a negative correlation. This number will be positive. So if you're looking just to do the correlation coefficient, it's a good idea to do that first. Okay, then we have something called r square. R square is literally the square of the r, right? So if you square this value, it'll give you that value. But what that means is it is the proportion of variability in the y caused by variability in the x. So what does that mean? Basically, it's how important is the x for determining the y. Okay? So you can imagine if the r square is 1, then 100% of the changes in y can be attributed to changes in x. So if you double x, you double y. This is saying that approximately 19% of the variation in the y, which is the number of eggs, is directly related to the mass of the mother. Okay, this value will go from 0 to 1, 0 meaning 0%, 1 meaning 100%. All right, that's our n right there, 23. Okay, so there's a bit of information here that you might need in some circumstances, but if you're reporting this, most of the time this should be enough. Most of the time this should be enough. You might need to have some more, but most of the time your p-value will be enough. Although, yeah, let's just leave it at that. Okay? No, I'm sorry. I'm not. I'm going to have to take a step further. So you will need these values here, these degrees of freedom, and you are going to need this f. I think you will need that to be reported. So what we do is we look here and we see, oh, our p is less than 0.05. Great, so that means our regression is significant. So how do we report that? Here we're it's simple. Longevity and mass are significantly negatively correlated. Okay, what we have to do now is be a bit more precise. Here we have to say there was a significant positive regression between, and there are other ways you can word this, but this is a good way to do it, between what is it, mass at maturity and clutch size or number of eggs. Okay, then you should tell them what it was, what your data were. So this is where you would have to report these things. You need to report f is equal to 4.967. The degrees of freedom, that's where you get this f from here. That's a statistic, like our t statistic. That's a statistic that we are testing. Our degrees of freedom is equal to 1, 21. All right. You have to report 2 degrees of freedom when you're doing the f. That's the way it is. Okay. Don't worry about y. Take a stats course and then you'll learn why. And our p is equal to 0.0369. All right. That's pretty good. A even better way to do it is to give a bit more information about what was the independent and what was the dependent variable. So you could say the number of eggs was significantly positively regressed on to mass. Or another way to put it, mass significantly increased, or even better, sorry, I'm thinking this off the top of my head. This is the best way to write it. Increasing mass significantly increased the number of eggs. That is probably the single best way to do it. And remember, you want to show them where those data are. So here, they're present in figure 1. Boom. Okay, so what I've just said, someone reading this can tell that as mass increases, it causes the number of eggs to increase. They can go find it in figure 1. Here are the statistics that support that. Now, if you need to know the equation, because a regression allows you to predict y from x. It does not allow you to predict x from y, but it allows you to predict y from x, and you can do that with an equation. So if you remember, maybe you remember from school or from math, y equals mx plus b, or sometimes in science we'll do it more, y is equal to ax plus b, where m or a is the slope and b is the intercept. This here is the intercept. So the intercept of this equation B is going to be 0.6912. This here, where it says mother mass and maturity, that is the slope. So this equation will be y is equal to 0.096 with rounding x plus that 6.9 6.912. Okay? All right. Now, you might ask, some people will ask this, is this value different from something or other? Is the intercept different from 0? You can look here at the 95% confidence intervals. If 0 is found within these intervals or any number, then you say it's not different from it. Okay, so the intercept, the point where the line crosses the y-axis, you could say it is not significantly different from 0. It's not significantly different from 5 or 10. I don't know. There could be some sort of value that you're comparing that to. This is the slope. The slope is significantly greater than 0. Okay, but it's significantly less than 0.2. If you don't need to worry about that, don't worry about it. That's fine. Okay. Now, the final thing I want to show you is that you can have Excel put into the figure the equation. So if you go to design, you select your figure, you go to design, add chart element, trend line, linear, it'll add a trend line, right? And that is the regression line, okay? If you go to more trend line options, you can have it, you don't necessarily need this, but you can have it display the equation and display our squared on the chart. And if you look, this equation here is what we have down here. I mean, there's a little difference of rounding, but there you go. Okay, so you've done the correlation, you've done a regression. This is significant. Do not put a line if you're doing correlation. Lines are only for regressions because you're saying one value is influencing and you can use it then to predict the other value. Correlation, you just leave it like this, right? No line whatsoever, because you're saying that they are related, but they're not necessarily directly related. There is no causation involved. All right. So I guess that's it. So remember, correlation shows only that there's a relationship, no causation, and regression does show causation. And there must be clear, independent, and dependent variables, right? There has to be, you should be able to say which one is causing the other one. All right, thank you very much. Hope you enjoyed.